Uh, so I'm on Zoom with Professor Avi Loeb, who is the professor of science at Harvard, and that's where he has also chaired the astronomy department for almost a decade, in fact, longer than anyone ever has. He also founded the Black Hole Initiative and is a chair on the National Academy's Physics and Astronomy Board. And that's just the beginning of a very long resume in astronomy, astrophysics, and cosmology. But now he has a new book coming out that is going to create a stir, and we're going to dig into it. So Professor Loeb, thanks for taking the time to talk with me today.
Thanks for having me.
So for much of your career, and it has been a pioneering one, studying far off things like black holes and the earliest days of the universe. But your new book, which is titled Extraterrestrial, is about Oumuamua, which people may remember was the first interstellar object that was seen passing through our solar system back in 2017. And it was weird for a number of reasons that we'll get into, and a number of astronomers have concluded that Oumuamua was likely an unusual comet or asteroid or some other kind of natural object that came from beyond our solar system. But you have a different hypothesis that you argue for and lay out in the book. Can you summarize for me what that hypothesis is?
Sure. So Oumuamua was the first object that we spotted close to Earth from outside the solar system. And it was discovered in October 2017. And as you said, astronomers naturally assumed that it must be a rock, just like all the rocks we have seen within the solar system, just coming from another planetary system around another star. But as we collected more data on it, it looked quite weird. Nothing like we have seen before. At first, astronomers thought maybe it's a comet because comets are the most loosely bound objects to the solar system. They reside in the Oort cloud at the periphery of the solar system, and they can easily be taken out of the solar system by passing stars. And so the same can apply to other systems, and you would assume that it's a rock covered with ice, so when it gets close to the sun, the ice would warm up and you'd get a cometary tail, and that was the expectation. However, there was no cometary tail. So it couldn't be a comet the way we know it, because in fact the Spitzer Space Telescope looked very deeply behind or around this object and put very tight limits on the amount of gas that could have evaporated from it, carbon-based molecules, dust. And of course, given the typical composition of comets, that ruled out the possibility of a comet. So then people said, well, maybe it's a rock, just like an asteroid that has no ice on the surface, doesn't evaporate. The problem with that is that about half a year later, there was a report that it exhibited an extra push away from the sun that is often associated with a cometary tail that didn't exist in this case. So a cometary tail gives a push to an object because of the rocket effect. As gases flow one way, they push the object the other way, just like a jet plane. But there wasn't any cometary tail in this case. And the question is, okay, well, then it cannot be a comet, but it can't be an asteroid either. Something is giving it a push, and what is that? And when you calculate how much mass should have evaporated in order to give it such a push, if it were a comet, it's about a tenth of the mass, a tenth of the weight of this object should have been evaporated. We couldn't miss that. It's some people say, oh yeah, maybe it's a small amount and we couldn't see it. Maybe it went into very large chunks or dust particles that we couldn't see, but it's a substantial fraction of the mass. We're talking about 10%. So it's not as if, you can eat the cake and keep it. You can't say one thing and then not satisfy the other constraint we have. And so it wasn't a comet, it wasn't an asteroid. What is it? And then also as it was tumbling around, it varied in flux, in brightness, because as it basically reflected sunlight, and the variation was a factor of 10, meaning that it has a very extreme geometry, 10 times longer than it is wide. Imagine a piece of paper tumbling in the wind. It will have a very small chance of being exactly edge on, and the amount of area that you see projected of that piece of paper if it changes by a factor of 10, that means the object is quite extreme in its geometry. Most likely flat, based on the reflected light versus time. It was tumbling over 8 hours. The conclusion was that at a 90% confidence, it is pancake-like, not cigar-shaped, as was depicted in cartoons. So a pancake-like object with an extreme geometry, and it turns out that it was also on the shiny end of all the objects we have seen before. And then it came from a very special frame of reference, which is sort of the local parking lot, the public parking lot of the galaxy, where you average over the motions of all the stars. It's called the local standard of rest. And only 1 in 500 stars is so much at rest relative to that frame as Oumuamua was. So it was just like a buoy on the surface of an ocean, with us, the solar system, being the ship that bumps into it. The question is, what is it and what could give it the extra push? And we suggested that it might be a technological artifact, a sail that is pushed by the sunlight as it reflects sunlight. And this concept of a light sail is currently being developed by us for space exploration. You don't need to carry the fuel if you are pushed by light. And it's a very convenient method to reach high speeds for relatively lightweight payloads. Of course, Oumuamua was the size of a football field. It was quite large, but we couldn't get an image of it because it was very far and unresolved, the point-like for our telescopes. And by the time we discovered it, it was already receding away. So it's like having a guest for dinner and realizing that the guest is weird only when he exits the front door and goes into the dark street.
So, okay, so to summarize really quickly, we have this strange object, the first object we've ever seen from passing through our solar system that definitely appeared to originate from beyond the solar system. And consequently, we've now seen, well, at least one more.
That's right.
A comet named Borisov, which actually did not turn out to be weird at all. It looked exactly and behaved exactly like a normal comet from our Oort cloud, but it was just on a trajectory that appeared to be from beyond the solar system. So this Oumuamua thing was the first from beyond our solar system, but not the last, and definitely weirder than ones that came later. And
well, it's, I mean, this Borisov object was discovered by a Russian amateur astronomer, Gennady Borisov, and it looked exactly like a comet that we are familiar with. And people asked me, doesn't that convince you that Oumuamua was also of natural origin? And I said, when I went to the first date with my wife, she looked special to me. And I met a lot of women since then, but she still looks special to me.
Okay. So some of the things that made Oumuamua particularly perplexing to scientists, as you just laid out, to just kind of paint the picture for people who haven't seen this, we're talking about a bright, reflective, probably pancake-shaped thing the size of perhaps a football field, acting like a comet, but without any of the things that we associate with comets, the outgassing, the tail, and moving in various weird ways. And so about a year after it was discovered, you put forth this light sail hypothesis and suggested that should be considered. And I think maybe it was a year after that a paper came out by a group of astronomers, including the people that discovered Oumuamua originally. And the gist of that paper essentially is, we think this is natural. There's a lot of things we don't understand, and there's a lot of properties that we can't explain, but we definitely don't think it is what Avi says it is. Well, is that a fair summary?
Well, I'm not surprised. I was not surprised by this, because if you show a cell phone to a caveman, that looked at the rocks all of his life, the caveman would conclude that the cell phone is just a well-polished rock, and obviously people tend to associate whatever they see with what they've seen before. You need to be open-minded in order to find wonderful things. Otherwise, you will never discover them if you always assume that the future is the same as the past. And my point is, this object was sufficiently peculiar to merit our attention, rather than have a group of people declare that it's not interesting or boring. It reminds me of, there was a book in the early 1930s written about why Einstein's theory of relativity is wrong. And there were tens of physicists signed on it. So Einstein was asked, what do you think about it? And he said, well, if it's wrong, then you need just one scientist to say why. You don't need a group of 30 people to make the case. And that's my point, that people come together often to establish authority. It's just like, in Africa, you have these herds of people feel more secure and powerful if they're in a group. But science is not about that. Science is not about authority. The authority of 1,000, as Galileo said, is not worth the sincere reasoning of a single individual. And the point is, just like basketball coaches, they tell their team members, keep your eyes on the ball, not on the audience. And so, having a large group of people is like keeping your eyes on the audience, looking around and seeing what other people say, trying to maximize the number of likes on Twitter. Who cares about, let's talk about the evidence. And in fact, there were a few groups of mainstream astronomers that tried to explain these peculiar properties that we talked about. So one explanation, using natural sources. One explanation was, maybe it's a dust bunny, of the kind that you find in a household, a collection of dust particles, the size of a football field, a very big dust bunny that is very porous, 100 times less dense than air. So it's sort of a cloud of dust being pushed by sunlight because it's lightweight. So that was one suggestion. And we've never seen anything like it. And it wouldn't, in my opinion, wouldn't survive the interstellar journey. Something 100 times less dense than air. And then another suggestion was, again, something that we have never seen before, a hydrogen iceberg, frozen hydrogen, a big chunk of pure hydrogen. So then that can evade the issue of not seeing a cometary tail because it's transparent. Hydrogen, when it evaporates, is transparent. The problem with that is it's not clear how you make such a chunk, and in fact, it wouldn't survive the journey. We wrote a paper with a colleague of mine, Thim Huang, showing that it would likely evaporate very quickly from absorbing starlight along its journey. It's very easy to evaporate hydrogen. So this just shows, and there was another suggestion of perhaps it was a bigger object that was disrupted when it passed close to a star, and then all the pieces, the shrapnel, are of weird geometries. The problem is most of the expected geometry is elongated from a tidal disruption by a star, whereas the most likely geometry from Oumuamua was flat, pancake-like. And also the chance of passing close to a star is quite small. So when people try to attend to the details, to pay attention to the ball, as I said, they went to explore things we have never seen before. And my point is, if we have to contemplate things we have never seen before, an artificial origin is one of them. So why not put it on the table and search the sky for more objects that look weird? It's just like walking on a beach, and most of the time you see seashells that are naturally produced. But every now and then you see a plastic bottle that is artificially produced, and that this Oumuamua may be just a message in a bottle. And one way to find out is simply by scanning the sky and finding one that approaches us so that we can come close to it with a CubeSat that is equipped with a camera to take a photograph from a close-up position.
You say for a couple of years now, you've been saying that this hypothesis is one that should be put on the table. But I feel like in reading your book, there's been a subtle shift, and not just, that wasn't the first time, but it feels like you've shifted a bit from, in the book, you say that you now see it as the most likely or as the simplest explanation. Am I reading too much in there, or has
No,
your
I
view?
think you're correct, because a couple of years passed by, and the community of quote unquote experts had that time to come up with natural scenarios that make more sense. And except for making the general statement, this group of people that made the general statement that, it's weird, but we are comfortable assuming that it's natural, except for that, the attempts to explain it, invoked things that we've never seen before that to me sound less plausible. So that increased my confidence that it's weird. And at the same time, I recognized something that is really unhealthy in the scientific culture right now. And, there are lots of complaints against our political system, right? But you would expect scientists to do two things: not be afraid of things that are unusual, that are new. If nature, physics is a dialogue with nature. We are supposed to pay attention to what nature tells us through experiments. And if evidence comes forward and looks unusual, we should respect it. I remember coming from a seminar just a year ago about Oumuamua at Harvard, and a colleague of mine who is mainstream conservative, worked on rocks in the solar system all of his life, he said, "This object is really weird. I wish it never existed." And such a statement has no place in science. You should accept all the evidence that nature gives you and regard it as blessing, because if it's different than you expected, then it teaches you something new. It's a learning experience. Nobody expected quantum mechanics the way it is, and we still don't fully understand it. And Einstein resisted spooky action at a distance, but he was wrong. And it's a learning experience through which we revise our notions about reality. And reality is the one thing that never goes away. The Earth continued to move around the sun, irrespective of whether Galileo was in house arrest or not. These objects exist out there, irrespective of whether we put blinders. So we should be open-minded and just judge what's out there by collecting data, by looking through telescopes. That's my point. And unless we check, if we assume that we know in advance what the truth is, we will miss an opportunity to discover something new. Now, the other thing that happened in the couple of years is that more data from the Kepler satellite was analyzed. And by now, just as of a few months ago, there was a paper about it. By now, we know that roughly half of all the sun-like stars, a substantial fraction of all the sun-like stars, have a planet the size of the Earth, roughly at the same distance as the Earth is from the sun. What that means is that all these billions of planet-sun systems have surface conditions on the planet that are potentially hospitable to liquid water and the chemistry of life as we know it. And so if you roll the dice billions of times, the conservative point of view that should be that of the mainstream, I should not be arguing about this. Everyone should accept that. The conventional mainstream view should be that we are not special or unique. It's arrogant to consider that possibility. The most modest and down-to-earth approach would be to say, under similar circumstances, you get similar outcomes. This is the conservative view, and we should say, yes, the most natural situation is that we are common. Not only that we are not alone, but that we are typical, okay? And that we are not special. And we are not the sharpest cookie in the jar. We are not the smartest kid on the block. There are things that are much better than us in that. So let's go out and find out the answer by observing. And given that the public is so excited about it, and the public funds science, how is that at all possible that the astronomy community considers that as a speculation? It's not a speculation. It's the most conservative approach. And let me give you an example. The astronomy community in the US every decade decides about its priorities for the next decade. So there are proposals on the table to build the next generation telescopes. And one of the big motivations is to search for oxygen in the atmosphere of a planet like the Earth as an indication for the existence of microbial life. So that's considered, in the mainstream as acceptable to discuss microbial life, looking for oxygen. That would be the way, or methane. The problem with that approach is that life existed on Earth for 2 billion years, roughly half of the lifetime of Earth. The first 2 billion years were with life, but not much oxygen in the atmosphere. So if you don't see oxygen, it doesn't tell you that there is no life, because Earth is the one example we know had life for 2 billion years without much oxygen in the atmosphere. So the second problem is that you can have oxygen, but that is naturally produced out of natural chemistry from breaking water molecules. And people will, after investing these billions of dollars, we would still not know for sure if there is life on those planets. How can we know for sure if using the same instruments, no extra investment of funds, using just the same instruments, we search for industrial pollution? So there are these CFC molecules in the Earth's atmosphere that refrigerating systems, industries produce. And if we find evidence for those, and I actually wrote a paper about it with a student of mine and a postdoc about 5 years ago, if the pollution is at the level of, let's say, 100 times what we are doing right now, it should be detectable with the next generation telescopes. So why not search for that? That's just a change in the frame of thinking, not so much in the investment of funds or the specific instruments that we're building. And that's the other thing that changed over the past couple of years in my view of the subject.
Digging back into the specifics of Oumuamua really quick, the one part of the light sail hypothesis that I get stuck on, and it didn't seem to be addressed. I haven't seen it addressed many places. It wasn't in the book in much detail. I may have missed it. But the notion that Oumuamua appeared to be, it was tumbling as it flew away from us, and that tumbling motion would seem to be counterproductive for any type of sail that I've ever seen in operation. Would that not be the case for a light sail?
Yeah, it would be. So it's, if it's a piece of equipment, it's probably defunct, or it may be just a surface layer of something else, a spaceship or something that was torn apart, or we don't know what the nature of it is. The key issue here on the table, as far as I'm concerned, is whether it's artificially made or naturally made. And you are right to say that it doesn't seem like it's functional because it was tumbling. I would agree with that.
Okay. Another thing that jumped out at me in the book is there's a line where you dismiss the notion that extraordinary claims require extraordinary evidence, which is kind of a popular truism. I think Carl Sagan made it popular. It's a standard that I'll often cite when confronted with the unceasing examples of supposed evidence for alien life that don't seem to have any merit. So what's wrong with that as a standard?
Well, so the word extraordinary really is quite subjective, because some people regard weakly interacting massive particles as the dark matter to be extraordinary, and other people might not. Some people might say axions are extraordinary, other people might not. So we don't know what the dark matter, most of the matter in the universe is, and assigning the word extraordinary is really dependent on who speaks, and I think science should be based on evidence, period. And of course, if you want an airtight argument, you want more evidence. But we should not dismiss options because the evidence is not tight enough. On the contrary, look at the search for dark matter. It was commonly assumed that weakly interacting massive particles are a possibility, and hundreds of millions of dollars were invested in experiments searching for it, but nothing was found, and the original hypothesis was ruled out. Now, this is not a waste of money, because science, is work in progress. It's a learning experience, and very often we are wrong. And so it's completely fine to take risks and be wrong. But to say in advance, we should not entertain some possibilities because the evidence is not extraordinary in their favor. If we were to adopt that, we would say, let's not search for weakly interacting massive particles. Now, look at theoretical physics. You have a large community of people, hundreds, if not thousands of practitioners working on extra dimensions and string theory. I mean, isn't that extraordinary? Do we have any evidence? We don't have any evidence. That is part of the mainstream. So on the one hand, what you find in the current landscape of physics, on the one hand, there are activities within the mainstream that are highly regarded, to which awards are being given, you know, from one person to another, and the honors are given, and honored societies select those people to be their members, and people think highly of themselves when they work on this subject, and all they are doing is intellectual gymnastics. There is not even evidence, not to speak about extraordinary evidence like you were asking for. There is no evidence, zero evidence, no evidence for extra dimensions, and no evidence for the multiverse, you know, ideas that are part of the mainstream. So, you know, I think it's hypocritical on the one hand to say, here are some anomalies. The anomalies are not sufficiently extraordinary for us to consider other possibilities than natural origin. Whereas at the same time, you have large communities of mainstream people highly regarded because they do mathematical gymnastics. And how can you accommodate both cultures at the same time? I think the correct approach is in the middle, saying, let's collect as much evidence as we can, but be guided by evidence and not dream things that have no, you know, guidance from experiments. Because nobody would have thought about quantum mechanics out of the blue by sitting in an office and contemplating possibilities. Quantum mechanics came about from experiments. So we should be guided by evidence and not dismiss possibility because the evidence is not tight enough, rather than try to get more. Now, the thing is, if you dismiss possibilities, you are not trying to collect more evidence, because you say, okay, everything we see on the sky is rocks. It's never aliens. You hear the same statement from those people. It's never aliens. What does that mean? It means it's not worth your time to collect the evidence. So obviously, if you don't look for the evidence, you will never find it. It's a self-fulfilling prophecy. And you also discourage, by bullying anyone that works on this, you discourage young talent from entering the field. So it's like stepping on the grass and saying, look, the grass doesn't grow. So you don't you bully anyone that works or try to work, then there is nobody of great talent that would find the next big thing. And at the same time, you freeze funding for this. And obviously, you can say, look, there is nothing being found. So my point is, first, you know, this is the reason why nothing is being found, because the community is not paying much attention to it. And second, that this is a subject where we are very likely to make major discoveries. And not only that, it would be the biggest discoveries that would affect our society. And the public is extremely interested. Now, you might say, okay, so why are scientists shying away? Isn't it their duty to respond to the interest of the public and to address a subject to which they have the instruments and the technology to follow, you know? It may well be because of the literature on science fiction and unsubstantiated reports on UFOs, unidentified flying objects. Now, let me ask you a question in that context. Suppose there was a lot of fictitious literature on COVID-19. People would have poems written about COVID-19 that make not much sense, and people would write some fiction about COVID-19 that makes no sense, and make films on COVID-19 that make no sense, and report about things that make. Would that mean that we should not develop a vaccine using the scientific method? No, scientists should address a question with the scientific tools they have, irrespective of what nonsense is being said about the same subject by other people. Why is that relevant?
I take your point, particularly with respect to things like the multiverse and supersymmetry, things that get mainstream attention. I mean, at the same time, there's certainly not any kind of a consensus around those things. Obviously, as you said, there's not even much evidence. So, I mean, is it in a way, isn't the same thing happening with Oumuamua, as you're simply putting out a hypothesis, and the more conservative end of the scientific establishment is pushing back on that? Is it different from how would you see it as different from the normal?
Of course, it's very different, because I would never write a paper or talk about this subject if there wasn't this evidence of the anomalies that Oumuamua showed relative to comets or asteroids that we have seen before. So the trigger for my entire set of publications on this subject, and I wrote scientific papers, a few dozen, and my book, the reason for that is the anomalies that we see. And I would never go that way if we hadn't seen the anomalies. So I'm actually being driven by what was seen. Now, it may not be enough to get to a firm conclusion, but it certainly motivates us to search the sky for objects that look the same. That we haven't expected that. We didn't take as much data as we want, but in the future we can find other objects. And in 3 years, the LSST survey of the Vera Rubin Observatory, for example, would be far more sensitive than the Pan-STARRS telescope that discovered Oumuamua, and it could find one per month. And then if one of these objects approaches us, we can send the camera close to it, take a photograph. And I would be the first to agree that, if we see a rock, then it's natural. But if we see something unusual, we should check it. But just saying that the evidence we got on Oumuamua does not justify even checking unusual objects that enter the solar system, that to me is a betrayal of the duty of a scientist.
One place I've been struck by the similarities and the differences between your hypothesis for Oumuamua is I've been struck by the difference between that and the alien megastructures hypothesis for the weird dimming behavior of Boyajian star, which some people just call like the alien megastructure star or the weirdest star in the universe with some of the names we gave it in the press about 2015. You had astronomers like Jason Wright from Penn State floating an extraterrestrial explanation there. But I don't think anyone else ever went as kind of all in as you have on your hypothesis here, to borrow a gambling phrase. I don't recall seeing anywhere near the pushback that you've received in your case from the very start. What do you think about the difference in those two instances?
Well, I think the people that, if indeed my hypothesis is correct, and in my book I talk about the Oumuamua wager, similar to Pascal's wager. If it's correct, then it's a much more immediate and close threat to the notions that alien life exists. So it's not only at a very distant star, system where it would take years for any signal to reach us, and therefore, it's not as it's in our backyard. So imagine a foreigner in your backyard that looks weird. You would react to it much more seriously than if you had the same foreigner in another country, in Canada, if you've heard about him, that weird person in Canada. So that's the way I interpret it. But I should say that, there was this congressman that for years used to make anti-gay statements. And then in March 2020, after he finished his term, he confessed that he is gay. So I would not be surprised if some of the harshest critics deep down are really excited about this possibility.
Sorry, mute button there.
Did you get what I said, or?
I did. Can you hear me? I lost the.
Yeah, I couldn't hear you just a few seconds ago, but the question is, did you hear me?
Yes, I got it. So I do have a bit of a theory of my own about the response you've received from the scientific community that is not at all scientific, and it leans very heavily on some pop psychology and my own non-expert observations. But can I run it by you real quick?
Sure, please go ahead.
So like a mystery like Oumuamua is, I feel like a perfect target for our own projections, and I think that the prevailing view in our society is one about pessimism about humanity. You and I both talk about space for a living quite a bit. You on a much higher level than me. And I don't know about you, but when I talk to average people at Thanksgiving or Passover, whatever it may be, about things like Elon Musk's vision for a city on Mars or breakthrough starshot and the ways that humanity can expand beyond Earth, the most common response I get is, something along the lines of, we can't even take care of this planet. Why should we go looking for others to mess up?
That's
or some other kind of pessimistic take. I think this is the majority outlook that gets projected onto Oumuamua, and it leads to a kind of knee-jerk dismissal of a hypothesis like yours, because it's too hard to imagine a society achieving such an accomplishment.
But you know what, let me just interrupt you for a second. You know what Oscar Wilde said? He said, all of us are in the gutters, but some of us are looking at the stars. And I can elaborate if you want.
Yeah, I think I know where you're going. And just to kind of finish up my point, I think you are a person with a more optimistic view about humanity and the universe, and that you're the outlier who would like to send out probes of our own into deep space carrying human DNA. You write about this in the book, to make sure that we can preserve our DNA beyond Earth. So in a way, I think you also project your almost totally opposite outlook onto Oumuamua. I don't know if you're right or wrong, but I know your outlook is more fun to think and talk about.
Yeah, no, I think you got it. And that's a very deep insight, I should say. I never heard it from anyone else, but I think you got it. And, recently I wrote a Scientific American article talking about Noah's spaceship. I don't know if you've seen it. The idea is that there is this biblical story in the Old Testament about Noah that was worried about the great flood and built an ark. And in fact, the dimensions of the ark are mentioned explicitly in the Bible. They are similar to the dimensions of Oumuamua by coincidence. But at any event, he put the animals into it and saved those animals from the flood. And we can think about doing the same. We need to think about something like that, because there are risks for humanity. All our eggs are in one basket right now. And all these people that talk about practical concerns, one of the practical concerns is that our civilization will not last beyond a few centuries from now. That we are sort of in the midpoint right now because we are developing the means for our own destruction. And the change in the climate is one example, but there are many more. And or it could be an asteroid that hits the Earth, or it could be the sun eventually within 1 billion years that will boil off all the oceans on Earth. So one way or another, we better spread our eggs in other baskets. And it's just like the story on the printing press of Gutenberg. The revolution that it brought about was that previously there were very few copies of the Bible. They were handwritten, and each of them was very precious. But once the printing press appeared, then multiple copies were easy to make. And then if something bad happened to one of them, it wasn't a big deal. So the same can apply to sending our life into space, into other planets, other objects. And you might think, oh, I need to build a huge spaceship and put elephants and whales and birds on it. But that's not true. All you need is a CubeSat that includes a computer system, advanced with artificial intelligence, that has all the information about the DNA making, the genetic making of these animals, and then a 3D printer that will make synthetic life on another planet out of the raw materials that are available there. And you just send it out to other places and make the life as we know it here elsewhere. And I think that's an elegant modern science approach to Noah's Ark.
That would be fascinating to see in action. You end the book drawing a parallel to Gil Levin, and he is not a household name, but he led the labeled release experiment on Mars with the Viking mission in the 1970s. And long story short, the experiment appeared to show some evidence of life, but it was never confirmed. To this day, NASA and what we might again call the scientific establishment, I suppose, considered a false positive. But Dr. Levin, meanwhile, he spent almost 4 decades now making the case that he believes a labeled release found evidence of life on Mars. And you mentioned him in the book to make a point, but I wonder if you've actually spoken with him about your experiences?
No, I haven't spoken with him. But, I haven't spoken with Galileo. I haven't spoken with Giordano Bruno. I haven't spoken with a lot of people that were dismissed at the time. Speaking about Giordano Bruno, I should mention an anecdote. There is a student in the English department at Harvard that was inspired by my book to do a PhD on a related subject. And she invited me to the PhD exam, the first one, in which one of the examiners asked her, "Do you know why Giordano Bruno was burnt at the stake?" And she said, "Well, he was an obnoxious guy and he irritated a lot of people." And of course, that's true. But then the professor corrected her and said, "No, it was because Giordano Bruno argued that other stars are just like the sun, and they could have a planet just like the Earth, and you could have life on those planets." And that was offensive to the church, because if that life far from Earth, if that life sinned, then they should have been visited by Christ to save them from their sin. And then you need duplicates of Christ. You can't just have one Christ on Earth. You have to have multiple Christs. And that was not acceptable, so they burned the guy. So when I heard that, I tried to introduce some scientific tone to the discussion, and I said, "Oh, that's very interesting." So in fact, we have an experimental test for that theology, because we now know that there are other stars just like the sun. So Giordano Bruno was right on that, and they have Earth-sized planets around them. Giordano Bruno was right on that. Suppose we discover life there, and we notice that it sins. Then we can simply ask them, "Did Christ visit you? Did you witness Christ?" And if they say, "No, we've never seen something like that in our history," that rules out this theology.
And I suppose you haven't heard from the Catholic Church on this matter.
Well, just to balance, I should say that there is this story about Martin Buber, a philosopher, that is told by Elie Wiesel, that said, the difference between Christianity and Judaism is that the Jews say that the Messiah will come in the future, never came. But the Christians say that he came already and he will come again. And so Buber says, why argue? Both sides agree that the Messiah will arrive in the future. When he arrives, or she arrives, we can just ask the Messiah, did you visit before? And that would settle the question. Again, an experimental test to a theology.
Right. Well, one thing everyone seems to agree on about Oumuamua is that it's weird on multiple levels, and that we're probably never going to see it again and never collect any more data to help solve the mystery. So does this ever get resolved?
Yes. So the problem was that we discovered it in October, when it was already receding away from us faster than any rocket we can produce. Whereas if we were to find it in July, and by the way, my family and I were visiting Maui and visiting the observatory, actually, at the time in July that year, 2017. So if it were to be found at that time, it was approaching us and we could have sent a camera to take a photograph of it. So we missed that opportunity. But if it's a member of a population of objects on random trajectories, then, for example, the Vera Rubin Observatory will see one per month. And so the point is that we will have many opportunities to collect much better data on future objects that look like it. And that's what we should do. At this point in time, it makes no sense to try and chase it, because it's already 1,000,000 times fainter than it was when it was closer to us. These objects get extremely dim, like one inverse of distance to the 4th power. So at the present, if you wanted to chase it, you would need a large telescope so that you can find where it is as you go in its path. But we also don't have the rocket that would move fast enough to do that.
Well, Professor Loeb, I have many more questions about the nitty-gritty of Oumuamua and some of your ideas and your career and these ideas about just kind of the state of science right now. But I think I've taken up enough of your time. Is there anything, though, that you really want to add or to say about the book before we go?
Yeah, so the book basically has 2 messages. One about Oumuamua being potentially the first technological artifact from outside the solar system. And the second is more about the scientific community, the culture that we have right now, which is not healthy and not supporting innovation as much as I would say the commercial sector does. Companies recognize that blue sky research and open-mindedness is beneficial commercially. And so if the commercial sector recognizes that, how can the academic world not recognize that and be twisted with ideas that are not testable by evidence? And it's just, the situation right now has to be corrected. And that's my second message. And I very much hope that the people will enjoy reading it.
It is. It's a great read. It's part a tale of discovery, part memoir, and part a sort of manifesto of sorts that you've been laying out for us over the last almost hour. So there's a lot in there, and it's called Extraterrestrial, and I believe it comes out January 26th. Is that right?
Exactly.
Okay, great. Well,